was that 1.1?
Yes.
Okay.
So earlier, I said inference, and I said I'm going to fill in the blank. What are we trying to infer, or what is the biggest set of interest? It is the population. We want to analyze the population. So a branch of statistics that deals with primarily inference is inferential statistics. So the area of statistics that simply describes the numerical attributes of the sample. We'll talk about the mean, median, mode, and whatnot. That area is what we call descriptive statistics. And by all means, descriptive statistics will lay the groundwork for inferential statistics. So we sort of collect the data, get some descriptive statistics, and move on to making inferences. Latex 1.2. Types of data. In a broad sense, we classify into two types, but these days you get all kinds of data. What are the two big types? First one is qualitative. What is the root word for qualitative?
Quality.
Quality. The second type is quantitative. And what is the root word for that? Quantity. So in a broad sense, we could classify data, sample, all the same, into two types. One is qualitative, the other is quantitative. Quality, quantity. So the observations, whatever you observe with qualitative data, are attributes of some sort. They are qualities of some sort. I will start with one. Now, before we get into the example, excuse me, what is population? Very good. Not COVID. Florida. So Florida is the population. And what are we interested in Florida? A hair color of people, or people in Florida, Floridians in general. Could we measure hair color as a number? No, it's not a numerical measurement. Hair color, black, brown, white, gray, etc. But I can't say 10.57. Yes? Typically when we analyze data. Of course, one may argue, if you're like software engineer or something, you'd say, oh, we'll convert it to RGB and then I'll put it as a number. Good for you. But simply speaking, that's not a numerical measurement. Can you think of something else? I hope it's not what I think would be the next one, but we'll see. Some sort of attribute. That's exactly what I thought was going to come. So, eye color. So, good. So now that we've looked at two easy cases, let's make it a bit more challenging and see if you can come up with more qualitative data. It is an attribute or property of some sort.
Age.
Age, can you measure age? Yes. So it's a measurement, right? It's a numerical quantity. What else?
People who are left-handed.
So, okay, is it the type of hand is what we call? Fine. It has a name. Dexterity. I think that's correct. Of individuals in terms of handwriting. Right. You can only measure it one of two, well, one of three ways. Left, right, and what's the next case?
Ambidextrous.
Ambidextrous, which is both. Right? I'm not a big fan of saying. I tried to write in both and it's awful left hand. So this is how I'll be able to collect an observation. I do the same thing that I did earlier if I went around and asked, who ate pizza, left or right-handed, right-handed, right-handed. So I can keep one going, and every observation that I collect would be one of those values. They are not numbers. What else? One more, and then we can move on. You don't give me enough examples. We're not going to move on. Do you want to move on or not? I would like to know that you understood. So give me something.
What about like nationality?
Nationality or ethnicity. You can't measure that as a number, correct? So that would be categorical or qualitative. One more. You can't say ethnicity, but we included that already. Something else.
Height.
You can measure that.
Okay. Genres of music.
Very good. Genres of music. You're getting somewhere. Go ahead.
Is this all qualitative?
Yes, all of them are qualitative. That's it. Thank you.
Types of cars.
Very Very good. Types of cons. I was waiting for this one. Typically, it pops up in the very first three. Okay, we've got plenty. I'm going to pick music genres. Who doesn't like music? So I'm going to take that example. How would we measure if I wanted to go and collect data and say favorite music genre? How would we collect that? Let's say I'll give you options too. Good enough, right? Of course, I could come up with more, but those are the ones that I am going to consider for my study. So if I went around and collected a sample from this list, let's see who's wearing blue. Or you could say none. We'll add that, none. I'm missing a whole lot of genres, none of those.
Rap.
Right, okay, so this is our sample.
Rap.
That's not blue, but go ahead. I like aquamarine.
Let's count it. Rock.
That's it. We'll count it back.
Okay. Country.
None. It's not there, right? So that's all I'm measuring.
Oh,
So it has to come
oh.
from there.
My bad.
It's okay.
Classic rock.
All right. That's violet. Purple. No, not cheap. Right. Go ahead. He was just enthusiastic. We'll just put it into the one bar. Right. Huh?
Rap as well.
Okay. So if I asked you a question based on the example, majority of FTC students like what?
Rap.
So did we infer something about FGCU students? We just made inference. Okay, this aside, I collected this sample using those levels, right? And she said country, I said I'm going to put none because these are my levels of measurement. Good. So it has to come from my levels of measurement. I'll wait for it. So in a similar manner, favorite movies, football teams that people like, baseball teams, so on and so on and so on. So, good. When we go to quantitative data, the observations are numerical measurements. In other words, quantities, numerical quantities. So qualities, you can't measure in a numerical scale. Quantities, you can measure in a numerical scale. And there are two types. One, discrete. Two, continuous. Discrete data is simply whole number type data. Or numerical counts. And if I asked number of people who watched this particular show, you either say 100, 150, 107. You're not going to say 107.159. Right. If I said 107.159, what is that 0.159? Your hand, half of your hand? Right? It doesn't make any sense. So whole number, and typically discrete type data are numerical counts. They are countable. Continuous data is just the opposite. They're uncountable. So you could take all kinds of decimal values. So observations are from the entire number line. So it could be anything. 1.279, 2.234, doesn't matter. Do we recognize the difference between the two? Yes. An easier way to remember, I tell my students always, any type of count is going to be a discrete type count. If you can count it, it is discrete. We will do some examples on this, but let me see if you can come up with some. I'll start number of cars with turbo engines in the parking lot, right outside. Do you think that that would be continuous? No, clearly it could be either 4 cars, 10, 14, but it can't be 14 and a half. That makes sense. It is a count. So that would be discrete. Yes? Let's see if you can come up with one.
Number of siblings.
Number of siblings, very good. I mean, if you don't like one of them, you can just say that person is 0.29. What else?
Number of people in this classroom with a shoe size of 10 or greater.
Okay. One more, I think we're getting the idea here. This one, number of students in start classes. I'm not measuring the shoe size, I'm measuring the count. So this is one start class, I'm going to count, okay, 30 of them. I'm going to go to the next start class, I'm going to count the number of people with shoe size greater than or equal to 10. So in this class, there are 30, the next class, 29, another class, 22, and so forth. So I see where the confusion is coming from. We're not measuring the shoe size directly, I'm measuring the number of people in start classes with the shoe size greater than or equal to 10. What else?
Stars on the US flag.
I'm going to say flags and not just US flag for a reason. If it's just a US flag, I know how many there are, right? 50. It's fixed as of today, 50. So that's not random at all. Do you agree? But if I looked at all countries and if I went and looked at every single flag and say how many stars there are, one would have 50, one's going to have just one, and so forth. Does that make sense? Okay, one more example.
The number of Democrats in Florida?
Number of Democrats in Florida. So all of these, and we're going.
I had a question. Sorry to interrupt you. For discrete data, it's countable stuff. Like, for example, of a number of siblings, you can count like, I don't know, but most people don't have like more than 5 siblings. Does it have to be stuff that's gonna be like not a huge number? Because like, for example, if you want to take like number of people in the US with health insurance, that's a lot of people. But it's theoretically countable because there's just so many.
As
Would that
long-
still be discrete?
Yes, as long as it is countable. it is
Okay.
great. You know, there comes the concept of, countably finite and infinite.
Okay.
So, it's countably finite. So
Okay.
we can go with that. So all of these are discrete. So anything that's going to fall in a scale that is completely different from this would be continuous. I'm going to start with something. Two significant digits are just decimal places that I'm talking about. The key part here is up to 2 significant digits. If you go and get a chocolate chip cookie, you're going to look in the back and say, it's 23 grams. I don't know if it is, but every single one is going to look at it and say 23 grams. But if I went and found a graduate chemistry student and I picked 100 Starbucks cookies, I give it to that student and they are going to go to the lab and analyze every single cookie and they're going to give me numbers, exact numbers. So I'm not going to write all 100 numbers. Let's just say the sample happens to be, do you believe that it would all have 23? Exactly.
No.
No way, right? So one 21.39, the other 22.22, 24.87, 20.89, 23.01, 27.82, right? The person is measuring up to 2 decimal values, being very scientific. So before we end, does that mean that Starbucks is lying to us?
Yes.
In a sense, right? They're not. When they say it's on an average basis, if you look at all of these values, they're about 23. But not every Starbucks cookie is the same. Does that make sense? Okay, we'll stop there. Have a good day.